It's generic in the sense that it applies purely to southeast Queensland, but it does cover wetter, drier and intermediate rainfall areas. And what we've done is we've made it generic by expressing the key parameters in terms of, you can read it, kilolitres per hectare, so it relates to the size of your catchment, and looking at the curves as ratios between the area supplied with water and the catchment area. So you'll have to go and have a look at the guidelines to get your head around the detail, but nevertheless, you can show that, and this particular one relates to low density residential, you can show that if you have 100 kilolitres per hectare of effective catchment, then and you have a certain ratio of catchment area to your supply area, then you can get a certain proportion of your non-potable water demand met from a stormwater harvesting supply. And we always, with these sort of water balance models, you always get this sort of curve where you get those short early gains for a little bit of storage, you get a flattening out, and then you get a long tail where the cost effectiveness declines very quickly. So we would propose that within that sort of red band is where you might find a more cost-effective system. Now, we've done these for other things, so there's one for medium density, one for high density, and one for open space. So those tools are in the guidelines if anybody's interested. Now, if you go back to this low density curve and actually try and work out what sort of areas you need to get 10% supply, that's when you start scaring yourself because the numbers look pretty horrible. But if I say that 10% of my 2025 demand is about 50 gigalitres of water a year, which is consistent with that water strategy chart, then I find that I need a total catchment area of about 55,000 hectares, which, if you turn that into low density residential, it's about 300,000 homes. And I suddenly think, well, those big numbers, but then southeast Queensland is actually projected to grow from whatever we are now, about 2.5 million, to about 5 million, 4.5, 5 million, within the next 30 or 40 years. So our projections say that we're going to be building another 1 million homes. So perhaps if we get stormwater harvesting into a substantial proportion of new development, we can start to do something significant. But it has to be substantial, there's no doubt about that. And just for interest, the total storage that relates to is about 1.9 gigalitres, which is about the 10th of the volume of Wivenhoe Dam, if that's of any relevance or interest to anybody. So I've never tried to do that sum before, but it's interesting to see the sorts of numbers you get when you start to accumulate these things. I'm going to have to skip through a couple of points I'd like to make here. One is that one thing about stormwater harvesting is that it really is just a small water supply. There's nothing unique about any of the science behind runoff, diversion, storage, treatment, distribution. What makes it a little bit different is that you're combining a number of disciplines which aren't necessarily used to working together to come up with a system. So if you're looking to develop a good stormwater harvesting scheme, you ideally need someone who knows about catchment hydrology, who knows about water treatment, and who knows about water supply systems. And that's a point we try and make quite strongly in our training that we do. The biggest challenges with stormwater harvesting really are the site-specific things of where do you divert from. There are an endless number of places you can divert stormwater from. There's stormwater in every nook and cranny when it's raining. The question is not so much where you take it from, but if you do take it, where do you put it? What opportunities do you have at a particular location to store water and to put it to some use? And I think that's probably one of the key challenges. And then you've got to distribute it. And I guess the challenge there is that you're then creating second pipe systems, which raises issues of cost and other concerns that authorities tend to raise. So there are a couple of challenges, but to me the opportunities you need to go looking for the opportunities, and they will be different in different places. No one-size-fits-all solution, and you might surprise yourself what you might find when you go looking. And an example there is that Homebush Bay Olympic site, which I was involved with quite some time ago. But in the middle of the Homebush Bay site is a 4,000 megalitre hole in the ground, so 4 million cubic metre hole in the ground, which is an old brick pit. What better place to store water than a ready-made hole in the ground? So these things exist in all sorts of places and are there to be found. An important thing that we've learned about stormwater diversion is that when you look at stormwater system design, you might end up with a pipeline running from a catchment of 1 metre diameter to carry a Q5 or a Q10 or a Q20 event. But when you look at the volumetric runoff from a catchment, you'll see that 95%, and this is a particular set of numbers done, I think, by Monash University, 95% of your runoff volume occurs in events more frequent than 1 in 4 months. Now, what that means is that the rate at which you need to divert is quite small compared to the capacity of the pipeline system you're diverting from. So at South Bank, we've got a 2 metre diameter stormwater pipe and we're diverting at 40 litres a second. So you learn these things as you go along, but all these things are important in terms of trying to come up with solutions which are cost effective and able to be constructed and able to be developed. I'll skip water quality, but it's an important issue to keep in mind. I apologise for this little bit of random animation in the middle of this, but it's important to remember that stormwater is polluted, and if you're going to use it for purposes where it may come into contact with the community or it'll be used in community facilities, then it will need to meet certain minimum standards, and there are guidelines for that, and there's some developing experience as to the level of treatment required to achieve that. Risk is an important thing to consider. All of our water design approaches within Australia, whether it's the Australian Drinking Water Guidelines or the water recycling guidelines, are all based on a risk approach. In other words, looking at the catchment, looking at the nature of the runoff from that catchment, and determining the level of treatment that you require based on the nature of your catchment. So if you've got a stormwater catchment, for example, which is pristine, it's a piece of national park with no development in it, then you would expect that the quality and therefore the risk associated with that catchment will be much lower than if you're harvesting from the CBD of Brisbane, where there's traffic, where there's all sorts of other activities, human activity, animal activity going on that are likely to contaminate. So you need to be aware of risk management methodologies. Another big issue is the question of, okay, I've built this system, it's a beautiful system, it can do all these things, but I'm the developer, I want to sell my blocks and move on, go and develop somewhere else. Who's going to take this system on? Who's going to own it? Who's going to take the statutory responsibility for maintaining water quality and protecting the community? So this question of ownership is one which we're grappling with projects where where they're community-based projects. And no simple answers. I mean, the obvious one is to transfer it to the Water Authority, such as QUU, but you've got to rely on their goodwill to be able to do that sort of thing. And hopefully in time there will be a critical mass build-up of projects, and the private enterprise will move in and fill a void and start providing services which will allow these things to operate in the long term. Because if people don't have confidence that these schemes will work in the long term, then they won't support them, because they figure that 5 years down the track it'll all fail and then the whole thing will end up back in their lap in any case.